Hello students. So now your first term exams are over. So now in this video we are going to start a new chapter, chapter number 12, algebraic expression. So first, before starting algebraic expression, we have to understand that in algebra there are two terms, constant and variable. So in algebra there are two terms, constant and variable. A symbol having a fixed numerical value is called a constant. So here, whenever a symbol which is having a fixed numeric value will be called a constant. Example 5, 20, 1000, etc. So 5, 20 and 1000. These all are the examples of a term, a constant, because all these numbers are having a fixed value. Next, a symbol which takes various numerical values is called a variable. So a symbol which is taking various numerical values. So here will be known as a variable. Example a, x, y and z. So these are your examples of a variable. So these all the variables can take any numerical value. A combination of constants and variables. So when we combine constant and variables are connected by the sign of addition, subtraction, multiplication and division is called an algebraic expression. So whenever we combine constant and variables with the sign of addition, subtraction, multiplication and division, that will be called an algebraic expression. Example, this 2 is your constant, a and b is your variable. So here when we multiply them we get 2 into a into b gives you 2ab. So 2ab will be your algebraic expression. Next, terms. Various parts of an algebraic expression which are separated by the sign of plus or minus are called the terms of the expression. So here the parts of an algebraic expression which are separated by the sign of plus or minus are called the terms of the expression. Example, the expression is 3x plus 2y minus 4z. So this is your, in this there are three terms. First is 3x plus 2y minus 4z is an expression having 3x, 2y and minus 4z as its terms. So these all three are the terms of this expression. Now the next is types of algebraic expression. In types of algebraic expression, the first is monomial. Expression containing one term is called a monomial. So here the expression which is having a one term is known as a monomial. Example 5x square y or 3 upon 2 a b square and c cube. So these are your two expressions which having a single term, that is known as monomial. Second is binomial. Expression containing two terms is called a binomial. So here the expression whenever having two terms is called a binomial, like example x plus 3 or 5 minus 2x. So these two are your binomial terms. Next, third is trinomial. Expression containing three terms is called a trinomial. So whenever in expression having three terms is called a trinomial. Example 2x minus y plus 3. This expression is having three terms, that is known as trinomial. Next is quadrinomial. Expression containing four terms is called a quadrinomial. So expression having four terms is called a quadrinomial, like example square plus b square plus c square plus 5. 1, 2, 3, 4. So there are four terms, that is known as quadrinomial. Next is polynomial. Expression containing two or more terms is called a polynomial. So whenever any expression having two or more terms, so that means from binomial, trinomial and quadrinomial. This all comes under your polynomial, that is known as a polynomial. Next is your constant term, the term of the expression having no literal, that is literal means variable. So whenever any expression having no variable factor is called a constant term. Example, so the expression is 5x plus 7, and in this 5x plus 7, the 7 is not having any variable. So that's why 7 is a constant term. The next heading is coefficient in a term of an algebraic expression. So whenever any term in algebraic expression, any of the factors with the sign of the term. So any factor with the sign of the term is called the coefficient or the product of the other factors. So whenever any sign of the term having is called the coefficient of the product of the other factors. In, for example, in 3xy is your expression. The coefficient of y, that means here in 3xy the y is coming, so the coefficient of y will be 3x. So here that is a factor, that is a factor of y will be 3x. So this is your coefficient. Next, like and unlike terms. Terms having the same literal, that is variable factors, are called like terms. So here the terms which is having a same variable is known as like terms. Terms not having same literal, that is variable factors, are called unlike terms. So the terms which is not having a same variable factors are called unlike terms. Now exercise 12.1 of your book. Question number 1 is get the algebraic expression of following. So here we will be given a statements and we have to form an algebraic expression. The first is subtraction of z from y. So the algebraic expression of subtraction from z from y. So from y means, so y will come first, and subtraction means minus z. So y minus z will be your algebraic expression in this. Second is 1/2 of the numbers or the sum of numbers x and y. 1/2 of the sum. So 1/2 of the sum means the expression will be 1/2 of the sum of numbers x and y. So x and y you can keep in bracket. So the final expression will be, this one will get multiplied by x plus 1 y. So this will be x plus y upon 2. So this is your expression, x plus y upon 2. Third, 1/4 of the product of numbers p and q. So 1/4 of a product means 1/4 of a product means p multiplied by q. So 1/4 of a product means 1/4 multiplied by p upon q. The final expression will be 1 into p into q. This is pq upon 4. This is your pq upon 4 is your expression. The D part. Number 5 added to 3 times the product of numbers m and n. So 3 times. So here we are adding 5. We have to add to 3 times the product. 3 times the product means 3 multiplied by product of numbers m and n. 3 multiplied by m into n. After this you can add 5. So final expression will be 3 into m into n gives you 3mn plus 5. So this is your algebraic expression, 3mn plus 5. Now question number 2, show the terms and factors by tree diagram. So here in question number 2 we have to show the terms and factors by a tree diagram of these expressions. So first is x minus 3. So here we are going to draw a diagram showing terms and factors. So first we are going to separate the terms. Here in this expression the terms is first is x and second is minus 3y, minus 3. So first term is x and second term is minus 3. And what are the factors of x? The factors of x will be 1 into x. So 1 into x gives you x. So 1 and x are the factors of x. And what are the factors of minus 3? Minus 1 and 3. So minus 1 into 3 gives you minus 3. So minus 1 and 3 are the factors of minus 3. The next second expression is 5x y square plus 7x square y. So here again there are two terms. The first is 5x y square and second is 7x square y. So this first term is having the factors as 5. 5 is your first factor, second factor is x, and is y square. Y square means y and y. So 5x and y. These all are the factors of 5x y square. And next there is 7x square y. So here the factors will be 7 x and y. So 7 x y. These all are factors of 7x square y. So in this way we can draw a tree diagram showing the terms and the factors. The question number 3 is identify the numerical coefficients of terms other than constants in the following expressions. So here we have to find out the numerical coefficients of the terms that is other than constant. That means we have to not consider the constant. Constant means numbers in the following expression. The first is x plus 2xy plus 3y. So this is your expression, and here we have to identify the numerical coefficient. So there are three terms, first, second, third. So here in the x has one numerical coefficient, 2xy has 2 numerical coefficient, and 3y has 3 as numerical coefficient. X has 1 numerical coefficient, 2xy has 2, 3y has 3. So these all are your numerical coefficient. These all 3, 1, 2 and 3, these all are numerical coefficient. Now next, again there are two terms, minus p square q square plus 7pq. There are two terms, and out of these two terms only one term having a numerical, that is 7pq. The 7pq is having 7 as numerical coefficient. The first expression doesn't have any numerical coefficient. The third part is 2 bracket L plus B. In here 2 bracket L plus B is having the 2L having 2 numerical coefficient, 2B having 2 numerical coefficient. So we can multiply 2 with L and 2 with B also. So we can get 2L and 2B. 2L is having 2 and 2B is also having 2. So these two are your numerical coefficient in this expression. Here, question number 4. Here we have to classify which is monomial, binomial and trinomial. So here in this first we can see that it is y square. So y square means there is only single term. It is one term, that will be a monomial. Second expression having two terms, 5 minus 3t. 5 minus 3t means there are two terms, 5 and minus 3t. That is binomial. So this expression is your binomial. Third, in this we can see that expression is having z square minus 3z plus 8. There are three terms, z square minus 3z plus 8. That will be trinomial. In this way, we can classify them as monomial, binomial, and trinomial by counting the terms. Question number 5. Identify like terms in following. So this is the combination of the like terms, and here we have to identify and make a pair. So first we are going to take a single term. So first is minus xy square. So minus xy square, this we have taken, and here the second the pair of minus xy square will be minus 4yx. No, this is not a like term. Next we are going to take a, here it is xy square, that means the like term will be 2xy square. So the pair will be, these two will be your like term. This is your first pair. First pair is your like term. Next, this is over. So now we are going to take the next, that is minus 4yx square. So yx square, we have to find out which one is having yx square. Yx square. So yx square, you can see that here it is, here only they have changed the order, x square y, and here it is yx square. So this is your like term, 20x square y. So these two are having your, we are considered as a pair of like terms. After this, the next will be 8x square. So x square, this is over. So x square, this again, we can say that this is a like term of 8x square, that is minus 11x square. So these two are pairs. Now next, this is over, we are going to take 7y. So 7y. So 7y. Here we have to find out which term having a single y. Is there any term having a single y? In the question I have here, it is here. We can say that this y is a single term, that means 7y and y, they both are the pair of like terms. So this is over. Now next is minus 100x. So minus 100x is over. So now find out which term is having x. So this is here. So the like term of 100 minus 100x is 3x. So next we are going to take minus 11xy. So which term is having xy? This here. So the like term of minus 11xy is 2xy. And here the next pair, we can see that which is missing. It is, here we can see it is y, and y is different. So we can say, take it as 20. So 20x square y. So this is also over, and this is also over. So 20 here, which term is having x square y? So this is the only term left which is having x square y. So the like term of 20x square y is minus 6 x square y. So in this way we can find out a pair of like terms. So these all are the pairs of like terms of this question, and these all sums I have done in the exercise 12.1. I am giving you the same type of sums in homework as a worksheet. Understand them and try to solve them. Thank you.